All right, so today we're going to start section 3.3. And so what we're going to be doing is finding the future value of things called annuities. And also sinking funds. So first thing is an annuity is just any sequence of equal periodic payments. So remember, periodic just means every so often on a timetable of some sort. And so lots of things are technically annuities. Your home loan, if you're paying that off on a loan, is typically an annuity. Your car loan, if it's compounded interest, is going to be an annuity. But here's the formula that you would be given on an exam. But we're going to talk about how maybe there's some new variables in this formula. Now I'm going to give you the formula that the textbook gives you. It is not necessarily the same format as I've seen in most other books. It's kind of an oddball book in this way. So if you want future value, which I usually call FV, I think the book might call it something a little bit different, but I think it's easier if we call it something that kind of uses the letters of the word. So it's going to be payment times, and then this kind of large fraction, so we're going to put a bracket around it, and it's going to be 1 plus I to the m power minus 1 over I. Okay, notice I'm using I instead of R. Okay, I used R for rate in the previous formulas last week. And so I, just so you know, is always going to be R over N. Okay, it's the interest per period. So if the interest is compounded monthly, it's per month. If it's compounded annually, it's per year. And M is going to be the number of payments. And actually, let's change this to N. Sorry. Like I said, this book is kind of an oddball, so I'm trying to remember how this technical formulas look in this book. So let's say N is the number of payments, because we've been using M as the number of times per year interest is compounded, so we're going to stick with that. So change this formula to R over M as well. Okay, so let's make sure that we know this is really important. That's why I put a star by it, so I'm going to circle it. So in a lot of books, they don't even use the letter I. They just actually put the fraction R over M in the formula instead. Okay, but notice there's an I here and an I here, so R over M would go in both places. So FV stands for future value. So that would be the amount that would be paid / the amount that would be in the account after the payments were made. And PMT is what I use for payment. Okay, so before we look at a full-blown example, just because we're using this new letter I, let's look at this. So find I if the interest is 18% compounded monthly. Okay, so it is significant that we said monthly. We're trying to find I. Okay, so I is going to just be the stated interest rate divided by however many times per year that interest is compounded. Okay, so if it's monthly, how many times a year is it? We've talked about this. 12. So that would give you 0.015 or 1.15% per month. So we talked about this a bit last week, right? So what they do is they take the interest rate, they divide it by 12, but then they're going to calculate / figure the interest every single month, okay? Which is not the same, by the way, remember, as figuring it one time at 18%. Okay, so let's look at a formula that just straight up asks you for the future value, and then we're going to transition to kind of being able to read a problem and understanding that that's what it's asking for. So find the future value for the following information. Let's say the payment is $1,000 a month for 10 years at 10% per year compounded monthly. So notice you're asked to find the future value and you're told that you're compounded monthly. Okay. So the future value is the amount you will eventually pay with this $1,000 a month. Okay. So the future value is going to be, now let's follow the formula we have above. It's not on screen anymore, right? But you've got it in your notes. So what's the payment amount? 1,000, so that goes here. And then we're going to have a large bracket here, okay? And what's going to go on the bottom is whatever the interest is, okay? But remember, if you need to do this off to the side, let's do it, right? I is going to be what? 0.10 over 12, okay? So this one would not round as nicely as the quick example we just did. So I'm just going to keep it as a fraction. Remember, you only want to round how many times in a finance problem? Only one time, okay? And so then we're going to have 1 plus that same interest rate. And then raised to the number of payment power. So you have to think about that for a minute. So how many payments would we have? If we're monthly and we're doing it for 10 years, how many payments is that? 120. Or you could just write 10 times 20 here. Okay, remember the formulas from last week also had a multiplication in the exponent. Okay, and then you subtract off the number 1 on the top. Okay, so if you need to, let's also go ahead and mention that off to the side. N is going to be 10 times 12, or 120. Okay, so when you punch this in your calculator, one of the things is you typically just use a parentheses in place of the bracket. Think of a bracket just like an outer grouping symbol, but you also are going to need to put parentheses around this right here. Okay, so if you have a calculator, it's going to be good if you get that out and try to enter this in with me. Okay, and then we're going to talk about how reasonable we think the answer is. Okay, so we're going to do 1,000 times, okay, and then notice what we have. We have a bracket and 2 open parentheses. So how many parentheses should I technically use here then? 3 open parentheses, 1 for the bracket, 1 for each of the parentheses, okay? So it's like bracket, parentheses, parentheses, okay, because we're trying to group things together, and then we're going to say 1 plus 0.10 divided by 12, close that parentheses, right, and raise it to the what power? The 120th, okay? Notice my calculator, the newer ones will start to kind of size your parentheses, like it'll put the bigger ones on the outside, it'll make them larger. The older calculators don't necessarily do that, okay? So then I need to get out of the exponent, right, and I need to subtract 1. So now I need to close my parentheses for the numerator of that fraction, right? And then I still need to divide by the bottom, okay? But I'll need parentheses around that as well. So I'm going to go ahead and kind of insert them here. In other words, we've talked about this for a while, right? Anything with more than one piece, especially when it's a fraction, what did I tell you to put around it? Parentheses, right? So it's going to be 0.10 divided by 12. Close the parentheses for the denominator, and then finally close the parentheses for the overall thing. In other words, the bracket at the end. Okay, So some of these parentheses are necessary, some of them you can get away without doing, but I just do parentheses around everything so we don't have to try to remember this one needs it, this one doesn't. It's too hard to try to remember that. So if you push enter, you should get what I just got here. So let's go ahead and write that down. So it's 204,844.98 is what it rounds to. Yes, you need to include the dollars and the cents. Okay, don't just round it to the nearest dollar. We want to be as accurate as possible. Okay, so just so you know, this is the amount paid at the end. Okay, so this is the amount paid with interest. So this might be like a home loan or something, although typically home loans are for longer than 10 years, but could be a home loan, okay, $1,000 a month for 10 years. All right, so then what if I asked you what the interest was? So notice I'm putting a star by this. Your homework doesn't always ask you for this, but I am going to be interested in this, so you're going to need to make sure you know how to do this. So notice that this $204,844.98 includes interest, right? So this is the amount they paid for the loan. So if we want to know how much of that is interest, we actually need to know how much they actually paid in, right? Or how much the payment actually was. So how much was their payment again? $1,000 for how many times? How many times did they have to pay it? 120 times, right? So if you work this out, you're going to get the 204,844.98 minus 120,000. For a difference of 84,844.98. Okay. So in other words, what the item cost, or if they're saving money, they actually put in 120,000, right? And they got an extra $84,844.98 in what? What is this again? This is the interest amount. Okay, so notice, like, if you're saving money, that's interest you get added to your account, right? What if you're paying someone a loan, though?
You're paying that extra.
Yeah, that's extra that you're paying basically to borrow the money from someone else, i.e. a bank. Okay, so we're going to kind of look at that from both angles, right? We could be saving money and getting the interest ourselves, or on the flip side, we could be paying a bank or mortgage company the interest. So let's look at another one. So find the future value of 200 a quarter for 20 and a quarter years at 9% per year, compounded quarterly. And then also at the end, kind of like the last one, I want you to find the interest earned. So we're trying to find the future value, and we're compounding quarterly. Okay, by the way, you can have a payment frequency that is different than the compounding frequency. That is possible in the real finance world. We're not going to deal with any like that because it's just kind of weird and complicated. So we're just going to assume that whatever we're paying, however frequent we're paying, that's also how often that it's compounding. Okay, so we want to use our future value formula. So it's going to look like this. It's going to be payment times bracket and then a big fraction. Okay, so I like to actually draw it that way everything kind of gets put in its place. And then off to the side, let's figure out what I and M are. Maybe you don't need to do this on every problem, okay, but I do think it's helpful. So how would I figure out the interest?
0.09.
Yeah, it's 0.09, right, over how many times a year we're compounding, which is what? 4, okay. And then what about number of payments? Remember, that's what M is. It's going to be 4, but notice the number of years is weird, right? So how are we going to write 20 and a quarter? Yeah, 20.25. Okay, so this is going to be 81. Think of it like this. If you had 20 years, it would be 4 times 20 or 80 payments, right? But then you had one extra quarter, so one extra payment. Okay. So let's plug in everything. So this is going to be 0.09 over 4 here. On the top, we're going to get 1 plus 0.09 over 4 raised to the 81st power minus 1. And then don't forget to go in and insert what? Parentheses around the top, but also the what? Also the bottom. Okay. So notice the reason I'm doing those in red and a different color is because those aren't going to show up in your formula. Those are just the ones that we're inserting to make sure we get the right answer. Okay. So if you have your calculator, I want you to see if you can figure that out. And then I'm going to write the interest. Okay, so how would I do the interest? I would take whatever I'm going to get, right? And then I need to minus 200 times the 81 payments. So whatever I get, I'm just going to kind of repeat a couple times there. So if you don't have a calculator with you, then before you start on the homework, you need to make sure that you go back and try maybe a couple of the homework questions and make sure you're getting the same answer as we are. So you would do 200 times bracket, parentheses, parentheses, right? 1 plus 0.09 over 4 raised to the 81st power minus 1, close the parentheses for the numerator, and then divided by 0.09 divided by 4, close the parentheses on the denominator, and then close the overall parentheses. So you should have gotten $45,009.54.
If you get an error,
If you get an error, try to do the go-to thing, and it will try to tell you where it thinks your error is. It's probably in your parentheses somewhere. So I'm going to leave that up and make sure that you have the same number of opens and closes in the same spots, maybe. I can look at it after class, though, for
and
sure.
you just push it 3 times, there's not a special.
Yeah, there's nothing special. So let me, once you get that, let me know and I'll move it over. Because, it cuts off some of it. So it can take a little practice to make sure that you're getting the calculator button pushes right. But then when we want to find the interest, we just take that quantity minus the payment times the number of times we made that payment, right? So if you work that out, that would be the $45,009.54 minus 16,200 for a difference of $28,809.54.
And now it's just like a comment.
You got it?
Close in the bottom section.
Yeah. Okay, so just to make sure, this is the interest, and the reason we're subtracting this amount off is because this is the amount that was contributed. So if this was a savings account, the saver only contributed how much? They only contributed $16,200, right, over the course of 81 payments, paying at $200 each time. Okay, but they ended up with a lot more money because they earned what along the way? They earned interest. Okay. Okay, so far we've only done example problems where it just spells out that we want future value. So let's look at maybe some of the wordings that might give you an indication that that's what we want, even if it doesn't use the term future value. So let's say a couple wants to save for a down payment. For a house. And let's say that they save $300 per month into an account paying 6% compounded monthly. So the question is, how much will they have saved in 5 years? And then we'll also figure out how much of this would have been interest as well. All right, so they're going to save $300 per month in an account paying 6% compounded monthly. How much will they have saved in 5 years? Okay, now if they were just saving cash, that would be a very easy calculation. What would it be if they were just saving cash under their mattress or something? You would just take $300 times what? Times 12 times how many years? Times 5 years, right? But they're not just saving it as cash, right? They're actually earning what along the way? Interest, okay? So notice that we want to know what they're going to have in 5 years, okay? It's not so much that it's a future time that we're going to use future value, it's that we're going to include interest after the fact, okay? So note that the amount includes interest. So note that their final amount will include interest. So we need to use the future value formula. So now that we kind of have that out of the way, let's set it up. So it'll be future value equals 300 times the bracket that has a fraction built in it. Okay. Off to the side, if you wish, we can figure out what the interest rate is and how many payments there are. Okay. So what's the interest rate? Or how would I get it at least? Yeah, so well, 0.06 over 12 though, right? So we'd have to figure out what that is, okay? And then M is going to be the number of payments, right? So we're going to do 12 times 5 or 60. Okay. By the way, this interest rate actually turns into something pleasant, okay, because 6 is divisible by 12, frankly. So if you want to go ahead and figure out what I is and then put that in the formula instead of the fraction, you can. But when can you not do that? If the fraction comes out to be what? Yeah, like really like a repeating decimal of some sort. Okay, so I just always leave it as a fraction, but if you just really hate that, you can change it if you wish. And then remember the formula is 1 plus that interest I amount raised to the number of payments power and then minus 1. And then again, we're going to insert our own set of parentheses around the top and the bottom so that it does it correctly. Okay, so let's put a hold on that. We'll figure that out in a minute. Okay, so leave a blank there. But then I want to talk about a comparison quantity. So let's talk about how much they actually saved. We mentioned it before. So they saved / contributed. How much could I say they saved or contributed? $300 a month, right? For how many payments? 60 payments. Okay, so I don't even think we need a calculator for that. You can just do 3 times 6 and then tack on the number of zeros you have, right? So it would be how much? So 18,000, right? So 3 times 6 is 18 and then tack on 3 zeros. Okay. So by the way, what should our future value be compared to that then? This would be if they saved cash under their pillowcase or something, right? So then this amount should be what? More or less? Should be more, because what are they going to get to add along the way that they wouldn't get to add if they just saved cash? Interest, right? So I just wanted you to have kind of a comparison quantity, okay? So now let's go ahead and punch that in the calculator. So it's going to be 300 times 3 opens, right? 1 for the bracket, 2 for the parentheses, and then 1 plus 0.06 divided by 12, raised to the 60 payments power, minus 1 finishes off the numerator, and then divided by 0.06 divided by 12. Close the denominator parentheses and close the bracket. Okay, so it's going to take you some time. And again, if you didn't bring a calculator today, the first thing you should do before attempting the homework for this section is like try a couple of these and make sure that you're getting the same answer, so you can kind of stop there. So you get $20,931.01 if you round it. So notice that was just a bit more, right? Why wasn't it crazy amounts more?
It wasn't a long period of time.
Yeah, 5 years is a pretty short period of time. Okay, so the less time that you let the interest grow, the less money will have built up in that way. So then how would you find the interest then? You'd take that $20,931.01 and you would subtract off how much you actually had to put in the account, and the difference will be your what? Your interest. Okay. So, I mean, I'm still happy if I'm this person that's saving, right? I have an extra almost $3,000, but it's not, you know, like I said, crazy amounts more because it was for only 5 years.
It's still better than putting it in your bank.
Yeah, I mean, so it's still better than saving cash, but of course, why do people save cash? I mean, there's some older generation people that save cash and they don't trust the banks, right? Because they don't trust, one, that they're going to get 6%. Was that our interest rate? Yeah, they don't trust that they're going to get 6%. Okay, so with any investment, there is some risk, right? So that's why people still choose to save cash sometimes and forego this $2,931 because they don't want to take the risk. Yes.
But like a savings account for like Chase, are you guaranteed?
Yeah, the savings account, you're guaranteed. The FDIC, the federal government guarantees up to $250,000, I think, per account. So like people that are really wealthy will spread their money in different banks. $250,000 here, here, so that they're always insured. So yeah, in the Great Depression, you know, there was runs on the banks and people's money wasn't guaranteed. And if you were last to the bank or one of the last to the bank, you didn't get your money. So the FDIC has stepped in and said, hey, we can't have that chaos, basically. So any amount that's in your checking or savings is guaranteed. Okay? What's not guaranteed, though, would be like mutual fund investments, stock market, stuff like that.
And even your retirement.
Yeah, because that's based out of mutual funds. Yeah. Mutual funds are what really drive your retirement accounts most of the time. So, yeah, that's not guaranteed. But, you know, the general principle of the finance world is the more money and the more interest you want to get, the riskier it is. So it's kind of like gambling. It is gambling. Okay, so it's like I want more of a percentage for my money, and I'm going to gamble that I'm not going to lose it all. Okay, so it's like white collar gambling. That's essentially what investment can be. So it just matters, you know, how heavily you want to do that.
Yeah, I looked at our retirement in the middle of COVID and that.
Yeah, don't do that. That's a depressing thing. I just don't even look at mine because honestly, I'm not going to pull it out, and it's there for the long haul, so it's there for decades at a time, so I'm not going to worry too much about bad years or a bad stretch of years. All right, so we talked about annuities. Okay, so annuities are any sequence of periodic payments. Okay, so a sinking fund is where we find the payment for the annuity. So I'm going to underline this. So this is like maybe a little more useful sometimes. This is like how much would I need to save if this is what I want to have in the end. Okay, as opposed to I'm going to save this much and I'm going to just throw the dice and hope that I get what I need in the end. Okay, so this would be like I'm saving for this kind of expense, and how much would I need to save if I think I'm going to get this interest rate as I go. So here is the formula, and you're hopefully going to notice that it looks like the future value formula just kind of solved or switched around, and that's actually exactly what's happening here. Okay, so this is the same formula, but solved for payment instead of future value equals blah, blah, blah. Okay? But so when you use this is when you know the future value, like you know the value that you want to have or that you will have, but you want to know the payment. So I'm going to put this back up here and I'll move it in a minute. So what I was trying to say is these formulas are really one and the same. Here's the future value formula. I just put up the notes from earlier. So all this formula is just a reworking of this one. It would be like if we tried to solve for payment and we moved this guy to the other side of the equation. Okay, so essentially that's all that it is. Okay, I still stands for the same thing. So what is I still? It's going to be interest divided by the number of times per year, right? N is still going to be the number of payments. Okay, so let me switch kind of our wording here and show you how this is different. So this says what monthly deposit is needed to save $100,000 a month in 10 years if deposits are made monthly and if interest is 5.5% compounded monthly. All right, so let's kind of underline the significant parts here, right? It's asking for the monthly deposit. In other words, it's asking you for the payment. Okay, that's what a deposit means. Okay, so this is like you're saving money. It's asking you how many, or what does the amount need to be that you would save, so that in the end you have $100,000, right? So what does $100,000 kind of stand for then? It's the future value you'd like to have, right? Okay, so let's reasonably think this through. We're going to set it up, but notice that we won't have to save a full $100,000, right? Why won't we need to save the actual full $100,000? Because we're going to earn interest along the way, right? So this is the backwards version, right? We're trying to figure out what our payment needs to be. So we're going to set it up, but then we're going to come up with a comparison value. So the formula is payment equals. Okay, and then we're again going to have a fraction, and we'll talk about kind of what we need in that fraction in a minute. Okay, so before we do, let's figure out what I and N are. And in all the previous examples, I should have been using N instead of M, now that I just look at that. Okay, so like for example 2 and 3, when we found out I and M to the side, that really should have been the letter N. So not to be too confusing, but let's go ahead and change that. So like this should have been N. And again, the reason for it, and I'm not trying to be confusing, it's just that this textbook is actually different from all the other textbooks that we've ever used in this class, and that they use the letter N instead of the letter M. So change it to N in this example 2.
And N is always total amount of payments, right?
N is total amount of payments in this book.
Yeah, but
Yeah.
even on other sections.
Yes. M is the number of times per year. In, like Nancy, is the number of payments. So I just changed it back in example 2 and 3. Okay, so back to this example. So how would I figure out the interest? It would be 0.055, right? Make sure you move the decimal place twice, right? If you say 0.55, how much percentage interest is that? 55%, and that's crazy, right? You're going to get way, way, way different numbers. Over 12, because we're compounding how frequently? Monthly, right? So let's go ahead and underline that too. We're compounding monthly. And then N will be the number of payments we will need to make, right? So how do we figure that out? 5 or 10 years, right, times how many times a year? 12, right, for a total of how many payments? 120. Okay. So let's go ahead and work that out. So let's plug in what we've got, right? It's going to be 0.055 over 12. and then times the future value we expect to have saved up, right, which was 100,000. And then on the bottom, we get 1 plus that same fraction raised to the 120th power, and then minus 1. Okay, notice that looks exactly like what we did before. It's just this part's on the bottom instead of on the top now because we shifted the formula around. So you would need to insert parentheses here and here.
So we don't need a big bracket anymore?
You can, it's just not necessary in this one. Okay, so you won't see it in the actual formula that you're given in the book or on the help features or whatever because it's not technically needed. But if you were to put an extra set of parentheses around the whole thing, it's not going to change the answer at all. Okay, so an extra set's okay. You just don't want to have too few of parentheses. So let's see if we can get this quantity. Hang on, but before we do, let's figure out how much we contributed, though. Okay, so if we want to say that, I want to do this before we come up with our answer because I want to talk about how we're going to figure that out. Okay, so how are we going to figure out how much they contributed? We're going to need to take the payment amount we're about to get, right? And we're going to need to multiply it by $120. $120, 120 payments, I mean. Okay. So notice this time we're actually going to have to figure it out ahead of time. So let's go ahead and go back to that, which I know some of you were already entering it in. So 0.055 divided by 12 times the 100,000. And then divided by how many open parentheses do you need in the denominator? 2, right? 1 for the whole thing, and then 1 for the 1 plus fraction part, right? So 2 open parentheses. So it's 1 plus 0.055 divided by 12 raised to the 120th power. By the way, make sure you're careful, like don't just go punching them in. You have to push the right arrow to get out of the exponent there. Like once you're done doing the 120th power, you'll have to push right so that it'll let you do the minus 1 and won't put the minus 1 in the parentheses or in the exponent spot, I mean. And then we close with a single parentheses. Okay, your calculator often will give you an error if you have like too many closed parentheses, not enough open parentheses, or vice versa. So make sure you pay attention to that. But I got about 626.93. Now, you should expect answers that are somewhat smaller. Why? We're not figuring a final big amount. We're figuring the what? This is the monthly deposit / payment required, right? So it shouldn't be like $60,000 a month, right? Nobody can do that. So $626 is still actually a pretty good chunk of savings, right? But you're trying to come up with $100,000 in 10 years, so you're going to have to save to be able to do that. So that amount's going to go there, and then let's figure out what it is. So 626.93 times 120. And that's going to give you $75,231.60. Okay, so what does this amount represent? This is the amount that they actually will pull out of their pockets to invest. Yes? Oh, I did that before too. Yeah, so thank you for letting me know. So that should have been a 6, right? Just don't copy it down wrong like I just did. So 626.93 is what it should be. Okay. But I think if you multiply it out, you still get what I said there, which is the 75,231. So then how would I figure out what the interest is then? You just subtract, right? So how much did they actually get in the account? They only contributed this much, which means the difference between it was their what? Was their interest, right? So they have $100,000 in the account at the end, okay, but they only had to deposit $75,231.60 because along the way, what did they get to earn? Interest. Okay, so this is their final amount or their future amount. This is the amount contributed. And the difference is the interest. notice that the interest is always the difference between the amount you have and what you contributed. So if there's extra in the account, that extra must have been the what? Must have been the interest.
Okay, so with your rounding rule,
Mm-hmm.
we're rounding before we get these numbers. Because like on that one, I just carried over I did 100,000 minus and then the second answer.
Yeah.
And I got a different number. Will that count against us on my?
It won't. So, and your way actually is more accurate if you want to be honest. But this is actually how it would be figured. Okay. So in reality, though, at the end of the year, usually I don't know if you've ever noticed this on the payments, but usually like the last payment of the year sometimes will be different in pennies. And the reason is for the reason you just said. Because what she's asking is, let me get my calculator back up. So notice the answer wasn't perfectly $626.93. And so if you use this amount instead of the rounded penny amount, you'll get a little bit different, but it'll just be off by pennies. So typically what banks do in that circumstance is they just give you back that extra or charge you the extra depending on what it is at the end of the year. So we're just going to kind of ignore that fact just because I want to make it like dollars and cents nice, if that makes sense. Okay. So, but yeah, that's a good question. But this would be kind of like what I talked about last week where the guy was like siphoning off the partial dollars and cents. That's kind of what he was doing. He was saying, forget the extra 0.0001 cent, and he was just siphoning that off into his own account. So anyway. Okay, so we don't really have time to do a full other one, but how do you tell the difference between these two formulas? The first one is when you know the payment, right, and you want to find out what you'd have in the account at the end, right? What is the second sinking fund formula for? When you want to know the payment, right? When you don't know the payment yet, but you do know how much you want to have in the account at the end, okay? But notice both of them use future value in some way, right? Either I want to have this amount in the account at the end, or I do have this amount in the account at the end, right? So both of them involve future value. And notice both formulas, again, use future value because that's a quantity that you either know or you want to know in the end. Okay. All right, so definitely make sure you practice this. So we're going to finish this up next time, but we're also going to start other types of investments, okay, that are similar to this where maybe you don't know the ending amount, but maybe you know how much you have right now, okay? So that's called present value, and that's what we're going to get into next time.